Hello and welcome to this lecture on engineering surveying. ACED 02 is the course code. In this lecture, we're going to discuss about linear measurements. Let's begin with the class. I'm Dr. Praveena Rao, Assistant Professor in the Department of Civil Engineering from the Institute of Aeronautical Engineering. So these are the objectives of the course. Fundamentals of the first course objective is the students will be learning the fundamentals of surveying for measuring field parameters using traditional and modern instruments, designing of curves and path alignment at suitable locations by implementing the principles of geometry and trigonometry, and the applications of remote sensing in civil construction, alteration works, detecting land use and land cover, and creating base marks for visual reference. The course outcomes: summarize the importance of accurate and thorough note-taking, explain the principles and procedures involved in setting out, and utilize appropriate digital surveying instruments to acquire, process and analyze the field data. Course outcome 4 is to apply the principles of electronic distance measurement and explain the principles and interrelationships of terrestrial photogrammetry and flight planning, and analyze remote sensing data acquisition on platforms and sensors using satellite images. So these are the course outcomes of this course, that is engineering surveying. The syllabus is divided into 5 modules: Introduction to Surveying, Theodolite Survey and Curves, Advanced Surveying, Photogrammetric Surveying and Remote Sensing. So in the previous lecture, we have discussed about what are the principles of surveying. In this lecture, we are going to begin with linear measurements. So in linear measurements, the first topic that we need to understand is what is a survey station. So a survey station, as defined over here, are the points at the beginning and the end of a chain line. So survey stations, so for example, this is a chain line. There are 2 stations at the beginning and at the end. The first point is A and the next point is B. These points are known as survey stations. So these are the points at the beginning and the end of a chain line. They may also occur at convenient points on the chain line. So it may be possible there are some intermediate survey points also, which are the intermediate survey stations at some convenient points. These are also the survey station. So you can have main stations, as I have already mentioned. The starting and the end point of the traverse, that is A and B, are the main stations. Subsidiary stations are the intermediate stations, and there are something called tie stations. So let's discuss about main station. The stations taken along the boundary of an area as controlling points. So the main controlling points are known as the main stations. The lines joining the main stations are called main survey lines. So the line that joins the main stations are called main survey lines. The main survey line should cover the whole area to be surveyed. So the main station should be selected such that it covers all the main areas. The main stations are denoted by the letters A, B, C, D and denoted by the symbol delta. The chain lines are denoted by the subsidiary stations. So stations which are on the main survey line or any other survey line are known as subsidiary stations. So the stations which are lying on the main survey line or any other survey line are called subsidiary station. These stations are taken to run subsidiary lines by dividing the area into triangles. So as we take the main line and we take some subsidiary lines to convert the given plot into a number of triangles. These are known as the subsidiary stations. So these are the subsidiary stations which are taken for the purpose of dividing the area into triangles for checking the accuracy of triangles. These are denoted by the letters S1, S2 and S3 and given by the symbol denoted by this symbol. Tie stations. These are also subsidiary stations taken on the main survey line. The lines joining the tie stations are known as tie lines. Tie lines are mainly taken to fix the directions of adjacent sides of the chain survey map. These are also taken to form chain angles in chain traversing when triangulation is not possible. Sometimes tie lines are taken to locate interior details. So these are known as the tie stations. So let's look at what is a baseline. So the line on which the framework of the survey is built is known as the baseline. It is the most important line of the survey. Generally, the longest main survey line is considered as the baseline. This line should be taken through fairly level ground and should be measured very carefully. The magnetic bearings of the baseline are taken to fix the north line of the map. So, a baseline is the main line upon which all other measurements are taken as the main line. Check line. So, the line joining the apex point of a triangle to some fixed point on its base is known as a check line. It is taken to check the accuracy of the triangle. Sometimes this line helps to locate interior details. So, next point that we are going to look at is a offset. So, the lateral measurement taken from an object to the chain line is known as an offset. So, as you can see in this diagram, this is the main chain line and we are taking a perpendicular offset. So, this is a perpendicular offset. The offsets are taken to locate objects with reference to the chain line. They may be of two kinds. So, you can take perpendicular offset or you can take oblique offset at any other angle. So, let's look at the points to be considered during the selection of the survey stations. So, during the selection of survey stations, the following points should be considered. Firstly, the station should be so selected that the general principles of surveying are strictly followed. The stations should be intervisible. So, from one station to another station, my points from this point A to point B, it should be intervisible. The stations should be selected in such a way that well-conditioned triangles will be formed. So, we should have well-conditioned triangles. The baseline should be the longest of the main survey line. So, the baseline selected should be the longest of the main survey line. The survey lines should be taken through fairly level ground as far as practicable. The main survey lines should pass close to the boundary line of the area to be surveyed and the survey lines should be taken close to the object so that they can be located by short offsets. The tie stations should be suitably selected to fix the directions of adjacent side. The subsidiary stations should be suitably selected for taking check lines. So, for convenience of check lines, you should have adjacent sides and you should take shorter offsets. So, these are the required points to be considered during the selection of the stations. The stations should be so selected that obstacles to chaining are avoided. So, at all conditions, we have to prevent obstacles in chaining to the maximum possible criteria. The survey lines should be very close to the main roads as survey work may then be interrupted. So, we should not have survey lines very close to the main roads. So, the next type of surveying is known as compass surveying. So, all measurements cannot be linear. There are some angles from the traverse. When we are traversing from between 2 points, say consider A, B to C, the traverse, it is not always possible to have only linear measurements. There are deviations in angles. So, we need to measure this angle theta. In such cases, we need an instrument to measure the angle of declination. So, the concept of magnetic bearing was introduced. When a magnetic needle is suspended freely, it will show a direction which is known as the magnetic meridian. The angle that a line makes with the magnetic meridian is known as the magnetic bearing of a line. So, the magnetic bearing is the angle that the magnetic needle will show with the line, the angle that a line makes with the magnetic meridian. And what is the magnetic meridian? It is the north direction shown by a magnetic needle. So when a magnetic needle is suspended freely, it will show a direction which is known as magnetic meridian. The angle that the line makes with the magnetic meridian is called a magnetic bearing. So magnetic bearing can be expressed in two forms. It is called the whole circle bearing and the reduced or quadrantal bearing. So these are the two systems for measuring bearing, the whole circle bearing and the reduced or quadrantal bearing system. So before we go into the two systems of bearings, the first thing that we need to know is some of the definitions. So what is a true meridian? The line or the plane passing through the geographical north pole, geographical south pole and any point on the surface of the earth is known as the true meridian or the geographical meridian. And the true meridian at a station is constant. The true meridians passing through different points on the earth's surface are not parallel but converge towards the poles. For a survey in small areas, the true meridians passing through different points are assumed parallel. The angle between the true meridian and a line is known as the true bearing of the line. It is known as the azimuth. So we need to remember this point, that is the angle between the true meridian and a line is known as the true bearing of the line, and it is also known as azimuth. Magnetic meridian. So here we can look at when a magnetic needle is suspended freely and balanced properly unaffected by magnetic substances, it indicates a direction. This direction is known as the magnetic meridian. The angle between the magnetic meridian and a line is known as the magnetic bearing or simply the bearing of the line. So this is the example of the meridian. This is the true meridian which indicates the geographic north, and the magnetic meridian is the meridian as shown by the magnetic needle. And this angle that a line AB makes, this is the line AB, whichever angle it makes with the magnetic meridian is known as the magnetic bearing, and the angle made by the line and the geographic meridian or the true meridian is known as the true bearing. So there are two concepts that we need to remember. There is a true meridian and the angle made by a line is known as the true bearing, and there is a magnetic meridian and the line will make an angle with the magnetic meridian. That angle is known as the magnetic bearing. There is something called arbitrary meridian. So sometimes for the survey of a small area, a convenient direction is assumed as a meridian known as the arbitrary meridian. The angle between arbitrary meridian and a line is known as the arbitrary bearing. Similarly, there is a grid meridian. For preparing a map, some state agencies assume several lines parallel to the true meridian or for a particular zone. These lines are termed as grid lines, and the central line, the grid, is called a grid meridian. So the bearing of a line with respect to the grid meridian is known as the grid bearing of the line. So coming to the parts of a compass consists essentially of a magnetic needle, a graduated circle, a straight line of sight, and a box to house the above. So all these parts of the compass are housed or fitted inside a box. So we have a magnetic needle, a graduated circle, and a line and the line of sight. So there are two forms of compass, and they are called the prismatic compass and the surveyor's compass. So for measuring angles, we need compass, and there are two types of compass, that is a prismatic compass and a surveyor's compass, and the different parts of the compass are a magnetic needle, graduated circle, and a line of sight. So prismatic compass, the compass most commonly used by surveyors where speed is more important than accuracy. It is suitable in areas outside the cities. So a magnetic needle of broad form is balanced on a hard steel pointed pivot. And the accuracy of the magnetic compass depends on how much freely the needle is supported on the pivot. The top of the pointed pivot is protected by an agate cap. So these are the different parts of a prismatic compass. There is an aluminium graduated disc which is fixed on top of the needle. The graduations are from 0 to 360 in clockwise direction, and the north direction is treated as 0 degrees. So we are taking all measurements from the magnetic north. So this angle, this is treated as the 0 point or 0 degrees. From here all measurements are taken. The next one is a surveyor's compass. In this compass, there is no prism at viewing end but has a narrow slit. The graduated disc is fixed on a box and the magnetic needle is free to rotate above it. After fixing the line of sight, the reading is directly taken from the top of the glass cover. There is no necessity of using inverted graduation in this compass. The graduations are from 0 to 90 degrees, 0 being the north or south and 90 degrees being east or west. So an angle of 30 degrees to the north in the direction of east is written as north 30 degrees east. So that means we are going to write north 30 degrees east. So your compass is graduated at 0 degrees. So we can look at this diagram. This is the diagram of a prismatic compass and this is the image of a surveyor's compass. So this term is a very important term, magnetic dip. What is magnetic dip? It is in a perfectly balanced needle after magnetization will dip towards north in the northern hemisphere. In the southern hemisphere, it will dip towards the south. If it is taken to the pole of the earth, the needle will take the vertical position. The vertical angle between the horizontal at the point and the direction shown by perfectly balanced needle is known as the dip. It varies from point to point and 0 degrees at the equator, while at the magnetic poles it is 90 degrees. To counteract the dip of the needle, a sliding rider or weight is provided on the needle. So magnetic declination, the magnetic meridian and the true meridian may not coincide with each other. So the horizontal angle between these two meridians are known as the magnetic declination. So that means in a compass, your magnetic meridian and the geographical meridian, that is the true meridian. The true meridian and the magnetic meridian do not coincide. There are different points and the angle, the horizontal angle between these two meridians are known as the magnetic declination. If the north of the magnetic needle is to the east of the true meridian, the magnetic meridian is said to be eastern or positive. If the north of the end of the needle is on the west of the true meridian, it is said to be western or negative. So magnetic declination varies from time to time and also from place to place. To find a true meridian is to be established from astronomical observation. So maps are made with respect to the true meridian. So it may be noted that in the noon, sun is exactly on the geographic meridian. So with the help of a diagram, we can see what is eastern declination, that is positive, and what is western or negative declination. So when the magnetic meridian is on the east, it is called eastern, that is positive declination. East of the magnetic meridian is on the east of the true meridian, it is called eastern or positive declination. And when the magnetic meridian is towards the west, it is called western declination or negative declination. Designation of magnetic bearings. So magnetic bearings are designated by two systems, that is the whole circle bearing and the quadrantal bearing. So let's look at the whole circle bearing system. The magnetic bearing of a line measured clockwise from the north pole towards the line is known as whole circle bearing. So that means when we are considering this is the magnetic north, and whenever we are measuring any line, we are measuring the angle that it makes from the magnetic north, and that is known as the whole circle bearing. So there is a line AB, so we are going to measure the declination of this line AB from the North Pole. Such a bearing may have a value from 0 to 360 degrees. So, if I have another line here, A to D, the angle of decline, the magnetic bearing as per the whole circle bearing for line AD is to be measured from the north, and this is going to be in the clockwise direction. So that is varying from 0 to 360 degrees. The whole circle bearing of a line is obtained by a prismatic compass. So we can show it with the help of a diagram. So we can see that there is a line AB in the first quadrant. So this is the first quadrant, second quadrant, third quadrant and fourth quadrant. So whenever there is a line AB in the first quadrant, so the bearing of the line AB, the whole circle bearing of a line AB is going to be theta 1. It's always measured clockwise from the north. So for line AC, the whole circle bearing is from the north, that is theta 2, always measuring from the north in a clockwise direction. For this line AD, the whole circle bearing taken from the north, that is going to be theta 3. And similarly for the line AE, in the fourth quadrant, we are measuring the angle from the north, that is going to be in the clockwise direction, that is AE in the fourth quadrant, that is theta 4. These are the whole circle bearings of lines in different orientations. So quadrantal bearing, it is also known as reduced bearing. The magnetic bearing of a line measured clockwise or counterclockwise. So in this method, we can measure clockwise or counterclockwise as well. Then from the North Pole or the South Pole. So that means you can measure from North Pole as well as from South Pole. You can measure on both the directions. This system consists of 4 quadrants. So this is the northeast, this is southeast, this is southwest, and this is the northwest quadrant. The value of the quadrantal bearing varies from 0 to 90 degrees. So here we are measuring with respect to each quadrant, and the angle by each enclosed between each quadrant, that is 90 degrees. So the variation of the angle or the bearing is from 0 to 90 degrees. So we can look at this diagram. For line AB, the quadrantal bearing is going to be theta 1. For line AC, the quadrantal bearing is going to be theta 2, because it is in the second quadrant in the north. It is in the southeast quadrant, so we have to measure from south. So the measurement will be anti-clockwise or counterclockwise from the south pole. Similarly, for the line AD, we are going to measure from the south pole, that is going to be theta 3. Similarly, for this line AE, I am going to measure from the north pole, that is theta 4. So whichever quadrant, based on the quadrant the line is present in, we are going to use the bearings. So reduced bearing, when the whole circle bearing of a line is converted to quadrantal bearing, it is called reduced bearing. The reduced bearing is similar to quadrantal bearing. Its value lies from 0 to 90 degrees. But quadrants should be mentioned for proper designation. So here we are going to see how to convert a whole circle bearing to a reduced bearing. So as seen in the previous diagram, there is a line AB and it is lying in the first quadrant. Then the whole circle bearing is between 0 to 90 degrees. For such a line lying in the first quadrant, reduced bearing is equal to the whole circle bearing and it is in the northeast quadrant. For a line AC in the second quadrant, the angle is lying between 90 degrees and 180 degrees. For such a line, the reduced bearing is 180 degrees minus the whole circle bearing and it is lying in southeast quadrant. Similarly, when we go to line AD lying in the third quadrant, the angle lies between 180 degrees and 270 degrees. Therefore, the reduced bearing is whole circle bearing minus 180 degrees, which is lying in the southwest quadrant. The last one is the fourth quadrant. There is a line AF, and the angle or the whole circle bearing lies from 270 degrees to 360 degrees. The reduced bearing can be computed as 360 degrees minus whole circle bearing, and it is lying in the northwest quadrant. This is the conversion from reduced bearing to a whole circle bearing. For the line AB, the reduced bearing being north, alpha is the angle. So the angle of the line which it makes with the north, this is alpha, and this is east. That means there is a line AB which is lying in the northeast quadrant, and the angle being or the bearing being alpha. For such a line, whole circle bearing is equal to the reduced bearing, and the whole circle bearing is going to lie between 0 to 90 degrees. Similarly, if I take AC in the second quadrant, so we are measuring from southeast, and this is going to be the angle beta. So there is a line AC in the second quadrant in the southeast quadrant, and the angle being beta, it is the whole circle bearing is going to be 180 degrees minus the reduced bearing, and the whole circle bearing is going to lie between 90 degrees and 180 degrees. Line AD is in the third quadrant, and the angle is going to be theta. Then we are going to measure the whole circle bearing is going to be 180 degrees plus the reduced bearing, that is going to lie in the range of 180 degrees to 270 degrees. There is a line AF, and the angle being phi in the northwest quadrant. So the whole circle bearing is equal to 360 degrees minus the reduced bearing, and the range lying from 270 degrees to 360 degrees. So this is the conversion of a reduced bearing into a whole circle bearing. So there is a term called fore bearing and back bearing. So every line has two bearings. One is observed along the progress of the survey in the forward direction, and that is known as the fore bearing. And the other is when you are observing in the opposite direction or in the reverse direction, it is known as back bearing. So consider a line AB as shown in the figure. So this is my line AB. So when I am viewing in this direction, it is called fore bearing, and when I am viewing in the backward direction, it is called back bearing. So the bearing is measured at A along the progress of the survey A to B, and that is theta. So the angle of bearing theta is the fore bearing of the line. So with the help of this diagram, you can see at point A, this is the survey line. I am viewing from A to B. This angle theta with the north is the fore bearing, and when I am viewing backward from B, this angle that we measured backward, that is known as the back bearing. So back bearing is equal to theta minus 180 degrees. So we can say that back bearing is equal to fore bearing plus or minus 180 degrees. So traversing, as already stated in the last section. So surveying which involves a series of connected lines is known as traverse legs. The sides of a traverse are known as traverse legs, and in traversing, the lengths of the lines are measured by chain and the directions are fixed by compass or a theodolite. A traverse may be of two types, open and closed. So this is an example of a closed traverse where we start the traverse at point A and we are traversing or we are chaining and then coming back to point A, then it is known as the closed traverse. So it is represented as A, B, C, D, E and back to A. So the polygon is closed. Therefore, it's called a closed traverse. When a series of connected lines form a closed circuit, when the finishing point coincides with the starting point of a survey, it is called a closed traverse. So it is used for the survey boundaries of ponds, forests and estates. So it is used for closed traverse. The next one is open traverse, when a sequence of connected lines extends along a general direction and does not return to the starting point. That is, I am going from A to B to C to D and E. I do not go back. There is no return. There is only forward movement. Then it is called as open traverse. So it is represented as A, B, C, D, E. It is done for mainly highways and canals where you have to traverse in the forward direction. There is no need to move in the backward direction. Therefore, it is known as a open traverse. So methods of traversing include chain surveying by chain, compass traversing by free needle, and theodolite traversing by fast needle, and there is plane table traversing by a plane table. So these are the references for this lecture. B.C. Punma and Ashok Jain. These are the main textbooks to be referred for this course. Thank you for joining.
Like, share and subscribe. Hit the bell icon for more updates.